All right. Are we ready for our last big topic, right? The last thing um, that we really got to get through for the college side of this. We will do more after this with gas laws and or acids and bases, but this is the last big thing that we need for our 3 credit college credit class. So we're almost there. Then we, can do a couple other things, get ready for a final, and call her a day almost. So last topic. We just got done last week doing stoichiometry, and we're still doing that this week, but we're making it slightly more realistic, right? And that's called limiting reactants. And the idea behind limiting reactants is we must find out which compound runs out first. So last week, either I only gave you one number, or I said that something's in excess. And so what I want you to think of is when we're doing these problems, what part is going to run out first? Because at that point, the chemical reaction is over. And so that's what we're trying to do. What we're really trying to do is we're trying to figure out 2 words. What do we have? And we're going to do that versus what do we need to complete the reaction? Okay, so you're going to see me use those 2 things as we go through this problem and the next one I post also. So I have this made up problem right here, right? Thinking about this, and we'll use it, and then we'll do some stoichiometry. So it says, in a synthesis reaction to make NH3, you start with 3.5 moles of hydrogen gas and 1.5 moles of nitrogen gas. How much NH3 can we make? So knowing this chemistry, we first must start with a balanced chemical equation, right? So it says we're going to make NH3. That's great. So I'm going to write down my arrow. This pen always messes up. And I'm going to write NH3 right here because we know that we have to do stoichiometry in order to solve any of these problems, right? In order to start with one thing and say what we're going to make from something else, we got to do stoichiometry. And so it says I'm going to have hydrogen gas plus nitrogen gas. But remember, these guys are diatomic, so I need to put 2's right there. Okay, that's great. I have my chemical equation. Now I have to balance it, right? Going through the balancing, I need 3 moles of that, 1 mole of that, and 2 moles of that. Again, if you can do it in your head, that's good. You definitely need to be able to do it. The nice thing about this problem is basically everything we've done for 4 months is input into this problem right here. Okay, being able to write formulas, being able to speak formulas, being able to balance chemical equations, right? And then getting into this idea of what is a mole, how do we use it? We're getting to that right now. All right, so the difference in this problem and what we did last week is this, right? All of a sudden, we have 2 numbers. Right? And it's our goal, which of those 2, the 3.5 moles of hydrogen or the 1.5 moles of nitrogen is going to run out first. All right, last week we would have just said, all right, I have 3.5 moles of that guy and I have 1.5 moles of that guy, and I would have wrote some arrows, right? And I would have gone over here, but this is too many arrows. I got to figure out which one of those guys is going to run out first. Right? I don't want to do all of this. I got to figure out which one is going to go first. So that's what we're going to do. And the nice part about this problem is we're already at the moles. We can compare elements when we know their number of moles. Okay? And so that's what I'm going to do. I'm going to start with what I know, just like I would in any other problem. And what this is going to do, this is going to look a lot like 2 weeks ago when we did empirical formulas. It's got the same feel to it. So I'm going to start with what I know. I have 3.5 moles of H2, and I have 1.5 moles of N2. Okay, that's what I have. These are my halves. Oops, geez. All right, I'm going to write my ratio. All right, I'll do that in blue. It's the same ratio. They're just opposites of each other, right? So I'm going to put moles of H2 on the bottom, and I'm going to compare that to my N2, right? And I'm going to put moles of N2 on top. Vice versa down here, moles of N2 compared to moles of H2 on top. Again, mole to mole ratio, we know where that comes from. It just comes from the balanced chemical equation. So we can look back up there and we're like, all right, H2 is a 3 versus a 1, a 3 versus a 1. Moles of N2 will cancel, cancel, cancel. I'm not trying to cross out things too much because you'll see why. And so now we're going to get to our needs, right? And that's just putting an equal sign right there, doing our math. So I have 3.5 divided by 3, which gets me my 1.17 moles of N2. These are my needs. Okay. And then down here, I get 4.50 moles of H2. The math isn't hard. This is where the hard part comes in. So make sure you're listening closely. We have to understand what these numbers mean. You guys are good at math. You can go through these steps just not even really thinking about it, but this is why this is a time when people get confused, because you actually have to think about it. And all we really need to do is we need to compare these two things. And we can do it two ways. And I would always suggest doing it two ways. So the idea is if I use up all 3.5 moles of H2, I would need 1.7 or 1.17 moles. All right. So I know if I use up all of that, I would need that much. Do I have that much? It turns out I do, right? I got more than that. That says something. I'll come back to it, right? Do the same thing with the other numbers. If I used up all of that, 1.5 moles, right, I would need 4.50 moles of H2. Do I have 4.50 moles? Turns out I don't. And so what we just figured out is this guy right here we call the limit. When that's gone, the reaction's done. And we'll still have some of this left because as this reaction goes all the way through, we're going to use up that much stuff, right? That's how much we're going to use. And we can see over here, we started with this much. We're only going to use, we only need that much. And so this one, because there's extra, we say that this is in excess. Okay, so we have our limit, we have our excess. And that's all based on taking a look at our haves versus our needs. And again, we can do it the other way. If we use up all of that, we would need that much. We go back, nope, we don't have that much. So that's saying that this one's in excess versus which one's a limiting. So the one that we care the most about for most problems, depending on how they're worded, is the one that's a limit, because that is what we do our stoichiometry with, right? So once we figure this out, basically what we just did is like, oh, I don't need that guy anymore. Okay, now I do my stoichiometry the same way. So I'm trying to figure out how much NH3 I can produce. So I'm just going to quickly go through this. So I'm going to start with my 3.5 moles of H2, right? I'm already at my mole level, so I can just write moles of H2 on the bottom, and I'm crossing over, so I want to have my moles of NH3 on top. Okay, taking a look at the balanced chemical equation, there's a 2, there's a 3, right? Cancel that out. I wanted to know how much can I make. I probably should have been more specific, maybe say grams. Let's go to grams, all right? So I'm going to put down my moles of NH3, and there's one of them. Because I'm not using that number, I'm going to compare that to grams of NH3. And if I look at that, look it up, 14. So I have 17.03 grams. And so my final answer comes out to be 3.5 times 2 divided by 3 times 17.03. And I get 39.736 going on. All right. So what that is, we have two sig figs out here. So my final answer should have 2. In this case, I would have 40 about grams of NH3. That would be my best final answer based on sig figs. Oops, can't see what I just did there. Okay. Some of these questions take it a step further, and that's why you got to be able to do it this way, is the second part of the question is, okay, how much excess did we have, right? How much was left over? Because if we go into business, if we go into industry, and it's not just chemical industry, it's also anything else, maybe we can reuse whatever's in excess. Maybe we can put it in our next process, something like that. So in order to do what's in excess, we need to figure out how much we started with, the excess product, and subtract the part that we used up or the part that we needed, right? So in this case, I have 1.5 moles of N2. And what I used, I'm going to subtract out. So I used up, or I needed 1.17 moles of N2. Now we can do this because they have the same units. So when I subtract the two, I end up with 0.33 moles of N2. Now, I'm going to save that for the next problem, but if we wanted to, we could convert that to grams by multiplying by its molar mass, and we would have that there. But this is our first limiting reactant problem.